Hello, ladies and gentlemen. My name is Wang from Institut Stuttgart. Today, I would like to present a new research about the project platform with the title Processing and Characterization of an Ultra-Thin Image Sensor Chip in Flexible Foil System. The next session, I'll give you an overview of the project platform, and we'll be covering these next 4 key points. What is chip field patch technology? Which chip thickness we achieved? Which interconnection problem we had, and how did I solve it? At the end, I would like to give you some results of a hybrid system in foil with an ultra-thin image sensor. The project FlexCom has 3 partners: IMChips, INT, and IHF. The 3 institutes are working close together to develop a hybrid system in foil comprising an image sensor, an IF chip, and an antenna. The whole system is packaged into a polymer foil and has only 70 micrometer thickness. It is mechanical flexible and environmentally agnostic. Today, I would only talk about IMChips part, which mainly focus on the HySiF production and image sensor characterization. To produce HySiF, we developed chip film patch process, a wafer-based technology which combines the merits of high-performance ultra-thin silicon chips and flexible foil technology. The process begins with the treatment of a carrier substrate. We use silicon wafer. After the first spin coating of polyimide and PCB, a metal layer was applied to the wafer to ensure a high accuracy for the following lithograph and chip placement process. Then the ultra-thin silicon chips are placed into previous produced cavities using a fan placer. The chips are then covered by polyimide and PCB, followed by structuring using photolithograph and plasma etching process. Afterwards, alusicle was sputtered onto PCB layer, then structured to connect the pads on the chip and the pads on the foil. The whole foil system is built up layer by layer like a sandwich. And at the end, the foil can be cut by a laser cutter and released from the carrier wafer. So in order to investigate if the chip film patch process has an influence on the image sensor performance, the experiments were divided into 3 groups. So in group 1, we use a standard sensor chip as a reference. In group 2, we thinned down the chip to 30 micrometer. In group 3, the thin chip were mounted on a polymer foil using the chip film patch technology. All the 3 groups use the same ceramic package and were applied with the same measurement to get the transfer on sensitivity curves. So the results show us the ultra-thin image sensor in foil has a comparable characteristic with a non-thinned reference chip. Now it's time to produce HySiF on the wafer. But at the beginning of the project, we had interconnection problems from time to time. The reason is if the step between the top side of the chip and the wafer surface is too high, there is a risk that the spin coating process will not ensure a good covering at the chip edges and side walls. In this case, the polyimide will be etched through in etching process, and this leads to shortcut in the carbon packaging. A possible solution is to produce a deeper cavities so that the topograph can be minimized. However, this creates new problem. The metal circle will be broken if the metallization, in the metallization step, if the chip edge and if the chip edge and the cavity are separated by a deep trench. So to solve this problem, my solution is to use capillary force to planarization the trench. As we know, during the spin coating process, there are mainly 3 forces acting on the surface with trenches or topograph. There are gravity, centrifugal force, and capillary force. The gravity and centrifugal force are due to the spin coulter parameter unchangeable. So capillary force plays a role. This force can suck the material into the trench. According to the equation and the test results, we will say at the same cavity depth H, more material will flow into a narrower trench. And finally, at a point, 100% polarization could be achieved, which means the trenches are fulfilled with materials. As the next steps, a HySiF patch, including an embedded ultra-thin image sensor and its wiring, was fabricated. The full system will then connect to a test board by a connector to investigate their further characterizations. So several experiments were applied, and the results proved that this foil system has a good connectivity and is fully functional. With this foil system, we also tried to build a simple camera system with lens, and finally, we successfully get a real generated image. Now, I'd like to go through the summary and outlook very quickly. Today, I talk about producing hybrid systems in foil using chip-fill patch technology. I mentioned how did I solve the interconnection problems. And finally, I proved this foil system is fully functional. As next, we will add an RF chip and an antenna to the foil system, and it will happen in the next 3 months. At the end, I will thank this paper's advisor, Professor Burghartz, and all the co-authors. And for most, I will thank the German Research Foundation for financial support for the FlexCom project. Thank you for listening.